At the core of quantum information holography lies a profound and elegant concept: the universe as a holographic projection, where everything we observe is a reflection of deeper quantum geometries encoded in light and information. This concept is built on the idea that the singularity, the dense, information-rich core of a black hole, acts as a mirror to the event horizon, projecting quantum state vectors through entanglement. The event horizon is a mirror reflection of the singularity encoded through quantum entanglement. Every qubit on the event horizon is entangled with a corresponding qubit in the singularity. When a particle falls into a black hole, it interacts with the qubits in the singularity. This interaction changes the quantum state of the singularity's qubits, which is instantly mirrored on the event horizon through entanglement. This process is like watching a movie through a mirror. We don't see the actual objects, but its reflection. The singularity is the source, the event horizon is the mirror, and Hawking radiation creates the interference pattern that makes the reflection visible. At the Planck scale, space-time itself is composed of Bloch spheres, each representing a qubit. These qubits act as light clocks, where the spinning QSVs generate angular frequencies that define the evolution of the quantum state. Each Bloch sphere is like a mirror, and the entanglement between these spheres creates a system of quantum reflections. The time dilation between entangled Bloch spheres can be visualized as the bouncing of quantum information between mirrors, but in reality the information is entangled. The observable universe emerges from the sum-over histories of these quantum projections. Each QSV on a Bloch sphere contributes to the overall interference pattern on the event horizon. The phase and frequency of each QSV determine how it interferes with others, creating constructive and destructive interference patterns that manifest as physical phenomena, including mass and gravity. In QIH, this interference pattern is the universe itself. The Wheeler effect, where light interference creates mass, is a natural consequence of how the holographic projection of light clocks interacts with the event horizon. The relationship between energy, mass, and angular frequency in quantum information holography can be described as follows. When the reduced Planck's constant is multiplied by the angular frequency of a quantum state vector, the result is the energy of that state, which is also equivalent to the mass multiplied by the speed of light squared. Small black holes, acting as blazars, emit Hawking radiation with extremely high angular frequencies. These blazars are the most energetic lasers possible, encoding the maximum amount of information through quantum entanglement. Through quantum information holography, the universe is seen as a grand quantum mirror. The singularity and event horizon reflect each other through entangled Bloch spheres, where light clocks define the geometry of space-time. Mass, gravity, and the fabric of reality emerge as interference patterns of quantum state vectors. In this vision, reality is not a static object, but a dynamic holographic movie, where every event is a reflection of deeper quantum geometries encoded in the phase and frequency of light. The universe is a hall of mirrors, where every reflection reveals new layers of information. Quantum information holography is the theory of everything and is now empirically supported. QIH unifies quantum mechanics and general relativity by demonstrating that all physical phenomena are encoded as quantum state vectors projected through entangled qubits, with Hawking radiation as the universal observer and operator.